Hello everybody. Today's topic of discussion is addressing in a network. This is Usha, Assistant Professor, PG Department of Computer Applications from Fatima College, Madurai. We all know what a network is. So today's world revolves around the network called Internet. So what is a protocol suite that we use in an Internet environment? We make use of a TCP IP protocol suite. We all know that we are making use of TCP IP protocol suite in an internet. What is internet? It is nothing but interconnection of networks. So every computer in the world is connected to each and every computer all around the globe. So it is nothing but an interconnection of networks, which is shortly called as internet. And as I told you before, internet makes use of the TCP IP protocol suite. So when everything is connected together, you need to know the name of each and every system to get connected to that particular system, which is called as the address. You need the address of each and every system to get connected to that particular system. So what does this TCP IP protocol suite does towards this addressing, or what kinds of addresses are used in the TCP IP protocol suite in an internet environment? 4 levels of addressing are used in the internet or the network which is making use of the internet connections. The 4 addresses are physical, logical, port and specific addresses. I'll come again. There are 4 addresses in the TCP IP protocol suite to address the computers that are connected over the network, which is the internet, wherein every computer in the globe is connected to one another. So what are the 4 addresses? Physical, logical, port and specific. Let us find out what each address has to do, or how are they connected to each and every layer. We all know that in a TCP IP protocol suite, you have different layers. The underlying physical network layers and the data link layer, right? The physical layer and the data link layer, wherein the bits are transmitted or the frames are transmitted, they employ physical addresses. And the next layer is the network layer, wherein packets are transmitted from one network to the another network. Here, logical addresses are used. And above the network layer, you have the transport layer, wherein segments are transmitted from one process to another process. And here, we make use of the port addresses. And above the transport layer, you have the actual applications, right? Which is done through the application layer, and here we have the specific addresses. So physical layer and data link layer, where there is hop-to-hop transmission from one node to another node in the form of bits or frames, employ physical addresses. And network layer, where packets are transmitted from one network to another network, employ logical addresses. And the transport layer, where a segment of a message is transferred from one process to another process. From one process to another process, they employ port addresses. And above the transport layer, where we have the application layer, wherein the addressing is called as the specific addressing. So now let us look into each and every address one by one. The first is the physical address. What is a physical address? We saw that physical addresses are used by the physical and the data link layer, wherein hop-to-hop transmission takes place from one node to the another node. So every node in a network will have a specific address, will have a particular address. Okay, so this particular address within a network, please underline this, within a network, every node will have a particular address, and this address is included in the frames which are transmitted from one node to another node within a network. And this framing is done in the data link layer. Okay, so this is the lowest level of address. Let us see how this happens. See here, you have the first system sending a message to the last one. The address of the first system within the network is 10 and the address of the last system is 87. So whenever 10 wants to send some message to 87, it has to include both the source and the destination address in its frame. So the destination address is 87, it is set first, and then from where it is coming? From the node 10. So this is being included in the frame and the message is sent through the network. Okay, right? So see how this happens. This is your network and now 10 wants to send something to 87. So what 10 does? So 10 transmits the message to the arbiter or the router which is connected in the LAN or your local network. And now this arbiter, this switch will check with every node whether the destination matches with the destination that is given by 10. Now the first node is checked. No, it is not 87. So the packet gets discarded. And then it checks with the third one. Again, it is not 87. So again the packet gets discarded. And then it goes to the last system. And now the address matches. And so the frame is delivered here. So this is how physical addresses work. Okay, so this is where we employ physical addresses. And next comes the logical address. I told you logical addresses are used in the network layer wherein communication happens between one network and the other network. So physical address is enough if you want to communicate within a network. But when you want to cross over a network, you need a logical address or you need a network layer. So network layer employ logical addresses. So logical addresses are necessary in universal communication. If I have to communicate to a system which is located in California or Nigeria, I need this logical address because I am in my network and my network is connected to my service provider's network and my service provider's network is connected to the India's entire network and India's network is connected to California's network and again from California it is to one service provider and then to the destination to whom I want to send the message. So I need a universal communication. Physical addresses are managed by every local area network, so the addresses can be of any type. But logical addresses, they have to follow an international standard because it is going to be used all over the globe, and so it has to be standardized. So you need a universal addressing system which need to be followed all around the globe. So this address is completely independent of the underlying physical networks. So I am going to tell the destination network, the network to which my packet has to reach. So here in network layer we address the data as packets and in the data link layer we address the data as frames. So logical addresses transfers the packet of data from one network to the another network. So for transferring packets from one network to another network, physical addresses are not adequate. So because, as I told you, every network will have different formats. So we need to follow an international standard or a universal addressing system. So we go in for this logical addresses. Logical addresses are currently 32-bit addresses. So every logical address will uniquely identify a host or a node that is connected to the internet. So if I am here in India, in Tamil Nadu, with a system connected to the internet, I'll have an address. And nobody else in the world will have my address. So my address is unique in the entire internet. There are no two publicly addressed and visible hosts on the internet which can have the same IP address. IP addresses are unique all over the globe. Okay, that is how logical addresses are made. So logical addresses are used whenever you want to send data from one network to another network. So in the internet era, you have to have a logical address for your system to get connected to the internet. So this is all about the logical addresses. Now I want to give you a note here saying that the physical addresses will change from one hop to another hop, but the logical addresses always remain the same. Okay, so the logical addresses always remain the same. Every host will have a unique address and it will never change. It remains the same. How many networks you pass through, or whatever network you are getting connected to, your logical address will remain the same. Your physical addresses will change, but your logical address will never change. Okay, now let us move on to the port addresses, and so we have to climb up to the next layer, which is called as the transport layer. So transport layer is responsible for transferring the segments of data from one process to another process. Okay, so the IP address and the physical address in a network are going to quantify a data, right? So from which system to which system you are going to transfer the data in the form of frames or packets. Now, after reaching the system, to whom you have to deliver the data? If suppose I am posting a letter, okay, so the door number and the street number, it is synchronous to your physical address, and maybe the city name or the state name is for the logical address, and to whom I am addressing the letter to. So on reaching that particular location, only someone in the family or someone living in the house will be addressed for that particular letter. So that particular person to whom I have addressed the letter is synchronous to your port address. So to which process my data is going to reach? Suppose I might send a mail, or I might send a file using a file transfer protocol. So I am addressing here that the process which I am using is file transfer protocol. So I have to specify a particular address for a particular process. So the transfer of data is from one process to another process in the form of segments in the transport layer. And this process to process communication needs the address of the process. And this address is called as the port address. Okay. So reaching the host or the destination is not the final objective of data communication. So what we have to do? Every computer now is running multiple processes at the same time. So to which process my data has to reach? To which process I am addressing my data? That has to be specified, and that is called as the port address. So port address pertains to the transport layer. So let's see to this example. Computer A can communicate with computer C by using telnet or FTP or email. So to receive every process, the system as a whole will receive the data. So where the data will be delivered, actually it has to be delivered to the particular process, either telnet or FTP, to whomever it is being addressed to. So every process needs some address. And in the TCP IP model, every process is assigned an address which is called as the port address. Okay, so this is the case. See here, in the data link layer, you have the hop address, right? And in the network layer, you have the logical address. And in the transport layer, you have the process address, okay, which is called as the port address, right? So A and J are ports. Okay, so we are saying that process A is transferring something to process J. So this is what is called as port addressing. And again, I want to make a note down here. The same note, physical addresses will change or might change from hop to hop, but the logical and port addresses always remain the same. So physical addresses might change, but logical and port addresses will always be the same. Now coming to specific address. What is specific address? See, if all the addresses are given as numbers, we will not be able to remember them. To make it simple or to make it user friendly, okay, we cannot remember the IP address the network layer address, it will be in the form of numbers. So we will not be able to know. Try this. If if you want to search something, we go into google.co.in, because we can memorize the words easily. If google.co.in is represented by some set of numbers, say 192.168.62.16, how many websites we can remember? We cannot remember that. So to avoid that, or to make the addresses user friendly, we have made this specific addresses. Say for example your email address. How do we have your email address? Say ushabhakta@gmail.com. This is easily memorable. So anyone can remember this. But no one can remember a number, a sequence of numbers. So these addresses are called as specific addresses. And these addresses also represent a particular node, or where the data has to be sent to. And these addresses are made use of in the application layer. Okay, so these addresses might get changed when they come to the lower layers. It might change. It should have a port address, it should have a logical address, and also it should have a physical address. And everything will be decoded to reach a particular destination, and then the data will be received by the particular process. So these are the various addresses that is being used in the TCP IP protocol suite in an internet environment. So we have gone through 4 different types of addressing. The physical addressing pertaining to the physical and the data link layer, where frames are sent from one hop to another hop. And logical addresses are used in the network layer, where packets are sent from one network to another network. The logical address will not change, it remains the same. And in the transport layer, the segments of data are transferred from one process to another process, and port addresses are used to address the process. So port addresses are employed here in the transport layer. And above that, in the application layer, to make it user friendly, we make use of this specific addresses. Thank you for listening to me. Thank you.